Hi, I'm LIng Chin. Under the course of SEEE2523 Electromagnetic Field Theory, we are here carrying out an experiment related to the voltage and the magnetic field. Let's take a look at the experiment and the result, and let's discuss the theory behind it. The objective of this experiment is to investigate the voltage side of the attached battery toward the strength of a magnetic field produced. In other words, is to see the effect of voltage size in producing a magnetic field. Here are the variables in this experiment. The manipulating variable will be the size or the number of batteries, which indicate the size of voltage. The respondent variable will be the number of paperclip attractors, which indicate the magnetic field produced. Other than that, the variables that need to be fixed throughout the experiments will be the number of turns of coils on the screw, the core material used, which will be a screw in this experiment, and the wire used.
Hi, I'm Xing Xuan, and now I'm gonna introduce a bit about our procedures. The first one is the apparatus we need to prepare. Basically, first is the silicone tape. The second one is 1.5V battery. Third one is paperclip. Fourth one is the solenoid made by copper wire and screw. The fifth one is scissors, and for safety purpose, hand glove is prepared. So this is the list out of our procedure. First, we need to make a solenoid with a screw and a copper wire. Then the both end side of the wire will attach to the positive and negative side of the battery. The number of the paperclip that attract by the solenoid will be observed and recorded down. Finally, the whole experiment will repeat with voltage of 4.5V and 9V. So next will be our demonstration, and this demonstration is done by Xue Wen. First one is 1.5V. The magnetic field produced at the solenoid can attract one or two paper clips. And please be cautioned, please wear gloves for both hands in this experiment. The next one is 4.5V. So we connect 3 AA or AAA battery to produce a 4.5V. The magnetic field produced at the solenoid can attract 3 or 4 paperclips a time. Last one is 9V. Just like 4.5V, we connect 6 AA and AAA battery to achieve 9V. As you can see, the magnetic field produced at the solenoid can attract roughly up to 6 or 7 paperclips. So this is the result we recorded down. Next, I will pass to Min Loo.
Hi, I'm Min Loo. Let's talk about the discussion of this experiment project. This experiment was based on the theory of Biot-Savart law, magnetic field of a solenoid, and Ohm's law. Now, let's look into the Biot-Savart law. The law states that the intensity of the magnetic field is proportional to the magnitude of the current I. This equation derived from the Biot-Savart law is used to construct the magnetic field on the axis of a solenoid. The solenoid is formed by a number of turns of wire carrying current I with the length L and radius A. After that, the total magnetic field at a point along the axis of a solenoid can be obtained by integrating this equation. Here it shows the example of finding the magnetic field on the z-axis at z equal to 0. To investigate the relationship of the magnitude of voltage applied to the solenoid and the strength of the magnetic field produced, Ohm's law is very important in this experiment. When the voltage applied increases, the current increases, and hence the magnitude of the magnetic field increases. This can be proven by the result of this experiment, which showed that there was an increase in the number of paperclips attracted to the solenoid when the voltage applied increases. In conclusion, with the increase in the voltage applied to the solenoid, there will be an increase in the magnetic field strength of the solenoid. Hope you enjoy watching this video. Thank you.